Hey, Monaco here, coming to you today solo to help you understand a simulation that I'm asking you to do in your practice pack about balancing chemical equations to show the conservation of mass. Mr. Milks isn't here. He's over at World of Inquiry. I'm here recording this at my desk in my lab, in my office at Edison Tech. Got my nice pictures. Anyways, that's not the point of this. The point of this is to help you understand how to use this simulation to better understand balancing chemical equations. So on page 32 of your practice pack, there is a link to my favoriteest of science websites with simulations. It's PhET. I can control click this one and it'll open it up. You might have to copy and paste it, or go to phet.colorado.edu, plug, and type in balancing chemical equations into the search bar. It's an HTML5 sim, so it should work on any web browser. I'm not sure about your smartphones, but it probably will work on tablets and smartphones as well if you're using Google Chrome. I want you to do the introduction. And the introduction starts out looking pretty blank. You know, what am I supposed to do here? Well, we're going to show how to balance the equation that synthesizes or makes ammonia. You should choose a tool. I'm going to go with the balance because we're balancing equations. You might think maybe the bar graph's for you. That's fine. I'm going to stick with the balance. When you balance a chemical equation, what you're really doing is you're changing the number of molecules in the reactants and the product side so that the number and type of atoms of the reactants match the number and type of atoms of the products. Because in a chemical equation, you can only rearrange the reactants to make the products. You can't lose anything. You can't change subscripts and you can't lose any atoms. So that's what the process of balancing is all about. When you're manipulating your simulation, you should always start with 1 mole of each of your reactants and products, just to see if it's going to work out and what you have to do in the game. Now, let's break it down. What this is saying is 1 mole of N2 contains 2 nitrogen atoms. Fine. And that's a reactant. Now, on the other side, let's look for nitrogen. Blue. 1 mole of NH3 contains 1 nitrogen atom. Well, 2 is not equal to 1, so we're going to have to do something to the product side to get it to match. Let's go by adding another mole of NH3. Now my nitrogen, I got 2 nitrogen atoms on the reactants, 2 nitrogen atoms on the products, but since ammonia comes packaged with 3 hydrogen atoms attached to it, now our hydrogens are out of whack. My reactant side, I said I started with 2 hydrogens. My product says now you got 6. That would be creating 4 hydrogen atoms, and that just doesn't happen in a normal chemical equation. So what you do is you change the number of moles of the reactant to get it to balance. And when you do, the smiley face shows up in the introduction. There are 2 other introductory equations to balance: the decomposition of water and the combustion of methane. Remember, always start with at least 1 mole of each reactant and product so you can begin, you got somewhere to start to try and get things to balance. All right. Now, the point of doing this simulation is to get a handle on how this symbol, CH4, really represents a carbon with 4 hydrogens attached to it. And when you change the number of them, well, it changes everything that's attached to that carbon, so hydrogen as well. Now, when you're doing the game, there's 3 levels. 1's easiest, 2's medium, 3's hard. When you play the game, you don't get the balance tool or the bar graph, but you do get a nice visual of the particle models of the molecules and atoms and elements that we are involving here. So when you set your mole coefficients to 1 off the bat, it shows you a nice picture, and you can change it. It just keeps going. Okay, so the object here is to get things to balance out. I can see here I got 1 carbon atom on my reactants, 1 on the products, 2 on the products. So we know that the carbons don't balance. So we got to change things to see if we can get it into balance. You click check to see if you get it right. And if you get it right on the first try, boom, 2 points. You make a mistake first try, but you get it right second try, you get boom, 1 point. If you can't seem to make it work out, it's just going to give you the next problem after 2 tries. Okay, so I want you to use this simulation to understand balancing chemical equations, and I hope this supplemental video is going to help you out in this unit. Thanks for watching. Bye.